Hello. I'm Miles Tails per hour. We will learn about standing waves. Check out the latest update we have made. A standing wave, also known as a stationary wave, is a wave which oscillates in time but whose peak amplitude profile does not move in space. The peak amplitude of the wave oscillations at any point in space is constant with time, and the oscillations at different points throughout the wave are in phase. One is called a node, and the other called antinode. Node is when its amplitude is 0. And antinode is when its amplitude is maximum. You can see two waves in different colors help you to identify the direction. And the resultant wave is given with a thick solid line, means the sum of two waves. Standing waves were first noticed by Michael Faraday in 1831. Faraday observed standing waves on the surface of a liquid in a vibrating container. Franz Melder coined the term standing wave. This phenomenon can occur because the medium is moving in the opposite direction to the wave. Or it can arise in a stationary medium as a result of interference between two waves traveling in opposite directions. That is why we call resonance, in terms of frequency. For example, a tuning fork can produce frequency. You can note that the air particles vibrate. One is called the compression, when particles come closer, and the other rarefaction, when particles go farther. This causes a tone when the tuning fork is slightly hit with something. If we have two tuning forks, we can have two different frequencies. One is 400 Hz, and the other 410 Hz. You can hear this sound like this. The number of beats shows the difference between first and second frequency, like the ones we compare with stroboscopic effect. Thus, the difference shows you 10 beats in a second. Now, in terms of mathematical formulas on harmonic wave, y1 equals a sine of 2 pi x by lambda minus omega t. And the other, y2, we put a plus sign, which is a sine of 2 pi x by lambda plus omega t. A denotes as an amplitude of wave. Omega, the angular frequency in radians per second, is 2 pi times the frequency. Lambda, called its wavelength in meters. And x and t denotes the variables of longitudinal position and time respectively. You know, the basic trigonometric formula sin A plus sin B is equal to 2 sin A plus B by 2 and cosine A minus B by 2. When you sum up the two standing waves, y1 plus y2, we get 2a times sine of 2 pi x by lambda and cosine omega t. This equation describes a wave that oscillates in time, but has a spatial dependence that is stationary. At any point x, the amplitude of the oscillations is constant with value 2a sine 2 pi x by lambda. At locations which are even multiples of a quarter wavelength called the nodes, the amplitude is always 0, like 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda and so on. Which is same for the negative side. On the other hand, odd multiples of a quarter wavelength called the antinodes, its amplitude is maximum at lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on, which is same for the negative side. Examples you might have come across, such as sound waves, X-rays, visible light and others. But that's enough for this topic. Like, comment, and subscribe now.